Welcome back to the workshop for some examples on derivatives. We're going to run through these relatively quickly, and then there's some practice problems for you guys to handle as well. One quick comment is one of the examples that I have listed for us to take a look at. Previously, when I taught this course, the chapter that we're going to look at next is actually taught in Calc 1 for the way that I've been teaching it in the past. So one of these we actually can't do. So let's take a look at the examples that we have in a moment. All right, so f of x is x cubed. When we look at that function, we are just looking at that's essentially a polynomial in its most basic form, right? No coefficient, and it's a monomial. So the derivative here just utilizes the power rule. So f prime of x is equal to, bring the power down in front and reduce the power by 1. Power rule, easy enough. Let's see here. Next is we have a trigonometric function, which we didn't talk about, but we also have a composition because we're plugging x cubed into the sine function. So the derivative is, we need to use a chain rule. The outside function here, right, we're plugging x cubed into sine. So sine is the outside function. And the derivative of sine is, well, maybe you don't remember. So this is the formula sheet that I will likely share with you guys. It has all of our basic differentiation rules. A lot of these we haven't seen yet. So 1 through 18, I believe you should be familiar with. 19 through 36, we're actually going to add all of those in the next chapter, if I remember correctly. So let's see here, basic trigonometric functions, derivative of sine is cosine. That's what we wanted, right? Derivative of sine is cosine. All right, so take the derivative of the outside function, leave the inside the same, and then multiply by the derivative of the inside function. Oh, hey, look, we just did that. Derivative of x cubed is 3x squared. If you wanted to, usually you write the polynomial in front of the trigonometric function. So we might actually call this 3x squared times the cosine of x cubed. And now we don't have to worry about whether we used parentheses here or not. We are clearly not multiplying the 3x squared inside of the cosine. It is outside of the cosine. The x cubed is the only thing inside. All right, part C here, we will learn this later. Again, the sum content moves around slightly from one course to another, and chapter 6 of our text sometimes appears in Calc 1, but we are looking at it in Calc 2. So we can't do that right now. Here we have a product. We have a polynomial times a trigonometric function. Very similar to actually what we just found above. So the derivative is going to require us to use the product rule. So the product rule is pretty flexible. I'm going to take the derivative of the first thing, right? This is t squared times cosine of t. So 2 functions. Derivative of t squared is 2t. We keep the other the same, cosine of t. Then we add the first function, t squared, times the derivative of the second. Derivative of cosine is negative sine. Of course, there's just t inside the cosine, so we don't have to worry about that too much. Notice here that t is our variable instead of x. The function notation tells us that t is the variable, so we know that that is what we're taking the derivative with respect to. So we could actually, if we wanted to give this the, trying to remember what notation this is called, that doesn't matter. The other notation, this would be a ds dt. S is the function, t is the variable. You may also want to simplify this slightly. I wouldn't recommend, or I wouldn't say you have to factor it, because you could pull out a common factor of t. But anyway, 2t times cosine of t minus t squared sine t, and that's fine. Here we have a quotient, so we want to use the quotient rule. So r prime, oh, that's not r prime, there we go, of x is equal to, let's see here, if we use our differentiation rules, we said that it was high d low, so low d high. Stating it later. See, I still mess it up. Low d high minus high d low over the square of what's below. Excellent. So the denominator times the derivative of the numerator. x minus 1 times the derivative of the numerator would just be 2x, right? Derivative of x squared is 2x, derivative of 1 is 0, minus, now it is the numerator, x squared plus 1, times the derivative of the denominator, which is derivative of x is 1, derivative of negative 1 is 0. So just 1 divided by the square of what's below, x minus 1 squared. Now, I'm going to not finish this example just because I want to be done with it, but you should simplify this. And I'm going to leave that for you to do. So distribute, see if you can factor and find a common factor of x minus 1 in the numerator to be able to reduce that a little bit. Probably not going to be able to, but it seems like a possibility. So in fact, well, yeah, I'll leave that for you to figure out, but it looks like it is not. So we call it good there, it looks like. Yep, and that's practice. Excellent. So that is our review on differentiation. We'll take a look at integration in our next collection of videos. So I'll see you guys back in the workshop a little bit later.